All right, so questions for 75 through 79, because the two things I've been asked come after this. So remember, if we're copying down answers, we should probably ask to see it solved. I'm okay with you guys needing it solved here in class, but we shouldn't just copy things down. So if anyone needs to see anything.
Wait, for 4-79, I got 6.5 miles. Is that? I just rounded it.
Yeah, you rounded down, is what you did. Let me see if I had that one solved. 79. Yeah, so I think we maybe talked about this right at the end of class yesterday. If you rounded at the second decimal place, thank you for asking that question, John. I know that was a tough problem. So remember, they gave us minutes and they wanted hours. So we had to set up the amount of minutes they gave us over 60. And we could have done that division first, or if you type it in your calculator correctly, you can type all that in at one time. Whoop. But it comes out to be 6.545454, I think. So really, if we round at the second decimal place, it would round up. And if we round at the first decimal place, it should really be 6.6. So that would really actually be 6.6. I know you asked for 80. You need anything else before 80? So 80 was a request, and 84 on the back was a request. So if you're sitting there thinking, I need help on 80 or 84, you can thank your classmates that are bold enough to ask the questions. We should all be so bold. All right, let's go. We'll go green and red since it's December now. Guys, anyone else waiting to build some snowmen? December. Gotta bust out the snowman socks. There you go. Alright, I should have known better than to bring that up. But alright. Daisy and Alexandra each have a set of algebra tiles on their desk as described below. Visualize and or sketch each girl's tiles. Guys, visualize. You could just, think about this, right? So remember the x squareds like we used in class. If you heard any story from yesterday in 3B when I threw the x squared, I accidentally hit a student. They got free candy because of that. It was just the cardboard thing. Yeah, Katie, you missed it yesterday. I threw things. So the x squareds. Remember, these can go together. I'm going to start highlighting things. Guys, I think I'm going to ask that when we come back from winter break, we all have highlighters to use. So if you don't have highlighters, put those on your wish list here for winter break. So they each have some x squared tiles, right? And I'm just highlighting all those in the same color. They each have some x tiles, and I don't have the exact colors that we use in CPM, so I'm just going to kind of pick my own colors. And, ooh, good catch. And they each have some 1 tiles. So guys, if this is what your paper looks like, it makes me really happy. Like, for real. When I see kids highlighting stuff or circling stuff or underlining stuff, I'm like, yeah, we're doing it. We're doing math. So then, if the girls put their tiles together, how many of each type will they have? Well, now that I've color-coded, it makes my life a lot easier than it could be. 1, 2, 3, 4, 5 of the x squareds. And you could put a multiplication symbol here if you want. You don't have to. I highlighted in yellow and now realize I don't have a yellow pen, so we're going to use lime green. 1, 2, 3, 4, 5, 6, 7 X's. And then purple, because the 1 tiles that we use are purples. 1, 2, 3, 4, 5 of the 1s. Any questions on how we do that? So if your paper looks something like that, cha-ching. Anything close to that, and I'm happy. But we should be making it easier for our brain, right? Don't make it harder. And then 84 was requested, but that's on a different sheet for me. So Eve, that all makes sense? Sweet. All right, 84 on the back. Oh, this is a popular one. I've had this requested a couple times. So here's the deal, guys. When you draw a scale drawing, a lot of time you work in inches. I showed this in the afternoon class, so it would not be fair if I didn't show it to you. Guys, I don't just teach this stuff, and I had it up on my bulletin board, now I kind of cleaned it up. I don't just teach this stuff. I legit do these things. This is my house. Not a great drawing of it, but pretty close. Then I decided to make better drawings. So, better scale drawings. Look at this. You want to talk about common denominators being necessary when you add and subtract fractions? Give this a second to focus. Guys, on Black Friday, I went and made $600 installing flooring. I don't know if I told that to you guys yet, but I don't just teach math, I do it. And the reason I teach it is I want you guys to be able to do these things. Look, I had eighths and fourths, and I had to change everything to eighths. Which actually, this is wrong, because then I was tweaking my math and subtracting things, so don't trust what I wrote here. My brain is a complicated place. But order of operations, right? Grouping things in parentheses. I did not make this for you, right? I did this over the summer. Working in inches. And very small amounts of inches. Look at these numbers. 11 and 7/8, 11 and 15 16ths. You got to have really accurate saws to do this. This build, I made not a whole lot of money off this build because this was a previous coworker, so I did this for their son's wedding. So look at all this math. My chessboard, because I got bored and really wanted to color. So I colored a chessboard as I was doing the math of figuring out, okay, 13 and 7/16 inches. Some pretty accurate stuff. And here's a little castle that I can actually bring into school. I made that for a game that we play. All right. But all of that to say, please do math with me. Right? Like, we've got 6 months left just about 6 months left. And we got a lot to do. So please do your practice work and ask questions when we need. I love doing math, is really what I'm trying to say. Come do math with me. I love it. So, we've got a drawing that Daniel made. Maybe Daniel from 3B, right? He's going to paint his patio. I would suggest replacing it, but it's just me. We're going from 4 to 10, which is not super nice. If we don't know how to multiply, what do? Divide backwards. So grab that calculator if you need. I think I buried mine. 10 divided by 2 is 2.5. So this tells us we're multiplying by 2.5, but we're also changing it to feet. So what we actually say is it's times 2.5 feet per inch. And when you multiply by the number of inches, the inches would cancel out. And as long as you remember to convert to feet, that's okay. You don't have to write all this out quite yet. We'll get to that point. But so this 7, we're going to have to multiply by 2.5 and switch our inches into feet, which comes out to be a decimal number. Right? I think, what's it come out to be? 17.5 feet. So then, find the area of the patio. Guys, our mini mastery on Friday is going to be about proportional relationships, but I might throw an area problem on there because I think we're going to take that mini mastery in teams. So I think it'll be a group mastery, and I'm thinking it'll be open notes, open homework. So if you've cared about your homework, if you've cared about your notes, that'll be a benefit to you. So area is length times width, right? For a rectangle at least. If it was a triangle, we'd cut it in half. So 10 times 17.5. The multiplication by 10 bumps our decimal over, and we get 175. What would be the label? Feet squared. By tomorrow, I will have my dry erase board all set up with like a whole what's the label thing. I really am trying to get this through to you guys. And if one can of paint covers 125 square feet, how many should he buy? 2. Because I could divide this by 125 if I want, and I get more than 1. Right? Because if I'm going to say I need to divide to split this space up, if I kind of try to draw it, I think 1 can would cover about that much. So I definitely need a second one. Do you still? No, because you can't buy that many. This is a situation where we have to round. Right? So that's a really good question. Is 1.5 an acceptable answer? Not really. Because you can't go into Home Depot and get 1.5 cans. Now you could get a gallon and a quart, right? They have different sizes of cans. But a quart is actually a quarter. A quarter. Guys, it took me a long time to realize a quart was a fourth. I know, maybe I'm just silly, but a quart, like a quart of milk, is a fourth of a gallon. That's why they call it a quart. It's short for quarter. I seriously was way too old when I figured that out. So, yeah, 2 quarts would be half a gallon. But then 2 quarts is almost as expensive as a gallon. It's silly. It's really silly when you go to buy paint. Does this make sense? Any questions still? Any other questions from this homework? Hey, guys. Guess what? You won. So you're now tied for the lead. It's 2-2 and 1. So 1A, you got to keep this up. So on that note, our next homework collection is when? Thursday, so tomorrow. So this one will go up on there as well on Thursday. Guys, you could take the lead. You seem a lot less excited than I figured you might be. You are tied for the lead. You could take it on Thursday. So I think I'm going to announce it at 4 on Friday, because the next turn-in is on Thursday. So if this is not done, try to get it done today. Here's the rest of our answers if you want to check those. But since nobody asked me any questions, I'm guessing we don't have questions. But notice their answer for 84C. It's 2 cans. Ha, like the bird, 2 cans. Ha ha, 2 cans. It's 2. They should have a label there of cans, but you can't buy partial cans. So we round up to 2. Any other questions from this homework now that we're looking at the rest of the answers? John? You can if you want. I guess it doesn't really matter because I go ahead and grade it. It's not due until tomorrow. Or which one is this? 431? I forget, when is this due? Yeah, it's due tomorrow. It's technically due tomorrow. So today is the soft. If you got it, turn it in. Tomorrow is the it really needs to be turned in. All right, so yesterday, the what? Yeah. Those are tough. So negative times negative to make positive. B ends up needing a negative to make the negative when we multiply. The decimals, we're going to start to see more decimals, but not a ton of them. Remember, you can think in not decimals. You can bump over decimals. So I could think about this being like 2 and 3 and 5. Yes. Yeah, but we're going to dive into things. All right, so especially as we get into more perimeter and area problems, like we saw in last night's homework, we probably need to practice some more of that, like John was asking for yesterday. But the first thing we got to talk about is distributive properties. So get out a piece of graph paper. That should not be a surprise. What type of graph paper? Is that what you just said? Yeah. Are there different types of graph paper? Yeah. You know what? Let's go ahead. It's December. No, I got an idea here. We're gonna do this. And while you guys are getting out graph paper, because it seems like a lot of us need it. We'll get kind of Christmassy. Well, wintry, I should say. No, so here's my plan. Then you write in white. All right, 4.3.2. Distributive property. Yeah, I was just trying to kill a little bit of time there, really, while people got stuff out. All right. Sorry, go ahead. A pen? That's bold. Would you like a pen or a pencil? I'm going to give you options. Look at that. So we've had the distributive property like twice, maybe. I don't know. We saw it like a couple times on homework. Anyone want to explain to us what it is? Like, Deekshita, go ahead.
It's a method of multiplying two numbers.
If I were trying to think about how many Jolly Ranchers I might need to feed all of my classes, and I don't want to just give each of you one, I want to give each of you like 3, right? So if I decide I want to give each of you 3 Jolly Ranchers, but that's 3 Jolly Ranchers that I want to give to every student in our 1A class, right? So I'm just going to call this A. And then every student in my 3A class, and I'm just going to call that B because I can't call it A also. And then every student in my 3B class, and I'm just going to call that C because I can't call it the same thing. So I either have to add up all my students first or multiply every class by 3. But it wouldn't be fair to just multiply you guys by 3, right? I mean, you guys are like probably like, okay, that's fine, just multiply us, whatever. But what if I only multiplied my afternoon class? That's not fair, right? That's just not fair. So the distributive property is all about being fair, right? We got to make sure that if we're multiplying, we give it to every single thing. So before we dive into all of that, make sure that that's your header. We want to review these things. So John had asked a question that I don't think comes up yet here. Do you remember why you asked that question to me?
Because, well, because I had done the area for something that I shouldn't have been doing, but
I think you did perimeter for something that you shouldn't.
Yeah, I was thinking.
But it's not on your homework yet, right?
No.
Okay, because you keep making me think that it is on your homework.
Or at least I don't know.
Real quick, let's sketch these on our papers. I'm debating with how much time we have. I might come back to that. Nah, let's do it. If you want to come grab algebra tiles, do it. I'm going to give you at least 5 minutes because I'm really bad at this, of not giving you enough time. Sketch those in your notes. It can be easy sketches, or you can grab tiles and trace them if you want. Guys, nothing wrong with wanting to trace tiles. And like you could just trace the square and then work from there and freehand draw everything else. But I'm going to give you at least 5 minutes because actually I'm probably going to hang up a tiny bit of my bulletin board. So as I walk around, what I'm looking for is, does everyone's papers say distributive property like we asked you to have, right?
Yeah.
Me, myself, and myself.
The royal we. Me, myself, and I.
Yes, the royal we. Thank you. I want that you know that. You guys know so many things that just catch me off guard.
No, my family knows the royal we.
So, it's not a big deal, and I realized after class yesterday, I made somebody switch, and it didn't really matter. If you're tracing tiles, you can trace whatever color you want. The purple ones are bigger. I get they're easier to work with. Eventually, CPM is going to call the purple ones Y. That doesn't matter right now. So, if If I made you switch from purple to blue yesterday, sorry, I realized maybe you just want the bigger squares. So then we're going to find the perimeter, because area, we said, is starting to feel kind of a bit easier than perimeter. So chat with your team, right? Label all the way around the shape. I'm trying really hard to make sure I give you 5 minutes. Is my sand timer working? Ha! You ever seen a sand timer break?
No.
Yeah. Does this not work anymore? Did it get wet? I'm confused.
How did it get right? Because it's like, it's its own thing inside that case. How do you break these?
Well, it made the move. Now it might be working. I can't tell because it's a sand timer. That'd be sweet. Maybe I should get a bigger sand timer. Except most of those are longer than that. I'm going to start to label my stuff up on the board so you can check your labeling. But you should really be talking with your team. If you have any questions, please call me over. There's your labeling for A. There's your labeling for A. We should start to display your guys' notes in the hallway. We thought those bulletin boards were going to be bigger. We were kind of disappointed. So you can glance up there if you want. So I put my labels around there, kind of like what I'm looking for. So on the outside of the shape is where we like to write the perimeter. Wait, what? They sure don't look the same. Guys, I think Lucas lost it.
Yeah.
Lucas just said they're all the same, and I'm looking at my...
No, they're not all.
You're telling me those 3 very different shapes have the same perimeter? What? What? No, Lucas is right. In A, if we count our X's, 1, 2, 3, 4. And if we count our 1's, 1, 2, 3, 4, 5, 6, 7, 8. So we write that out like 4x plus 8. And Lucas stood strong and said, yeah, they're all the same. Yeah, Mr. Hudson, they're all the same. Guys, when I push back against you, that's just me trying to have a good time and make you defend your math. Be confident, right? When you solve something and you're like, this is the answer, be confident. So this shape, even though it's set up differently, guys, could Mr. Smith set up a mile lap in different ways? Yeah. So when we talk about a length, even a length that we don't know exactly what it is, like 4x plus 8, we don't actually know exactly what that is, right? Because we don't know what x is. But it's something plus 8. Right? Does that make sense? Like, we know the 8. The 8 is for sure. Whatever x is, we got 4 of them, but I don't know what it is. I sure hope it's not a mile because I'm not running 4 miles. I haven't ran 4 miles in a long time. And then here, x, 1, 1, 1, 1, 1, 1, 1, 1. Also, 4x plus 8. Questions? So now, Mr. Smith is like, oh, you guys need to know what x is. So he says, all right, we're going to talk about 1 if x is 6. Uh-oh. And then, because I told him, whoa, 6 is way too much, he said, all right, well, fine. What if x is 1/2? I would take that over that if we're talking about how far I'm running. But all right, solve both of these for that expression, that 4x plus 8. I got to pass these back before I forget. Write out your work. Write out your work. So in one situation, we're going to make x 6. And in another, a different situation, because I complained, we're going to make x 1/2. He totally goes on the flip side of things and says, fine, I'll make it less than 1. So I'm going to like split my workspace actually. Well, if they're all the same, then yeah, you're right. They'd probably all end up the same. So we said 4x plus 8, right? I'm going to solve it 2 different ways. When x is 6, and then when x is 1/2. You just find him sitting alone today. There's a seat over here. There's a couple open seats. Jesus is not here. So guys, we could just write like 4 times 6, like with the dot. But at this point, we're going to start to get used to using parentheses to show multiplication. So you don't have to rewrite this. If you wrote it with a dot for multiplication, that's fine. But when I write it up here, I'm going to put the parentheses. And here's why. It's not as important when my x is a whole number. Not that big of a deal, right? Because we know how to multiply whole numbers pretty well. But when our x is a not whole number, like when it's 1/2, it's a little bit easier. Sorry, I should scroll so we can see that. It's a little bit easier to look at. I said easier. It's a little easier to look at when I put it in parentheses and say, what is 4 of 1/2 or 4 times 1/2 or half of 4? What's half of 4? 2. So now we get 2 plus 8 over here. Maybe this is laps that we got to run. Hopefully it's not miles. What's 4 times 6? 24 plus 8. Oh, that's not very many meters. I can do that in this classroom right now. So what's this come out to be? And over here, what's this come out to be? 10. Questions? All right. John, this is what you brought up. Go ahead and sketch this on your notes real quick. And start chatting about, if we go to find the perimeter here, what's going to happen? What gets a little tricky? You know this one?
Yes.
Well, help other people know this one.
I'm not gonna say it.
Well, in like a minute or two, I'll let you say it.
I think I know what this kind of is.
We're trying to find the perimeter. Little hint here about where the trap door is. Because the adventure wouldn't be fun if there weren't any trap doors or like, poison darts or lava pits we have to rope swing across. Or a giant boulder chasing us down a cave. Y'all gotta have an Indiana Jones mentality. Alright, time to use cards to make sure everyone's awake. Eli! I don't remember if you were the last card yesterday or if you need to do the first card today, so we'll give you a good starter question. What's this length? X. Alright, good work. Aiden, what's this length? 1, or if we look at the entire bottom, we could call it 2. So you could say it's 1 and 1, or you could start labeling this with the entire length if you would like. And now let's see where the cards go. Franco, we still miss you, dude. Waiting to have you back. Carmen, what is this length? 1. Oh, man, you guys are so smart. What is, we shouldn't use red yet. What is, Mia, what is this length?
1.
Oh, yeah, that one's 1, too. You guys. Sorry if you can't see that very well. I'm trying to give each side its own color. And then Layla. Oh, those arrows. What is this? Is it? I thought we said this was X. Like the whole. I thought, like. I'll use another different blue color. I thought this. Somebody said that was X. That little red piece is X? It looks a lot smaller than X. Antonella? I don't know. Where are you getting the -1? Wait, so hold on. If I do this entire edge, what is that? That's X, right? So then if I gotta go back and say, well, I don't have that section, how much should I take away there? 1, but I'm also missing this section. So it's X minus 2. Because we're missing, what's a good color? We're missing this section. That's still eraser? Give me a pen. Why are you still eraser? Give me highlighter. I don't know. We're missing this section and this section, right? We don't have those. So that was -1, -2. So right there, in red, that is X minus 2. Or, guys, I'm real honest with you. Math sucks because you have to make choices. But there are multiple right choices and multiple wrong choices. And this is where, like, I get anxious about stuff. I'm like, I don't want to make the choices. Like, I tell my wife, like, choose what we're going to eat. I don't care. I don't want to make the choices. I got another route you could take. So put your pencil down for a second. What if I hadn't counted this one yet. Could I color that red? Yeah. Ooh, I gotta go back and erase this for a second. And since I didn't get up here yet, right here, could I color that red? Yeah. And if I put all my little red pieces together, that, but I gotta get rid of these. Get out. Okay. If I put all my red pieces together, what do we get? X, right? Because boom, 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 it'd be the whole length. So if you got highlighters and you work in code, there are multiple ways that we can kind of code this problem. But if we only look at those sections, it's not X because we took pieces out of it. Right? So however you want to solve it is up to you. I got to go back and fix things. So that was one we said. The red section we said was X minus 2. Let's put some things together because that bounced some things all around the screen and how to prove I can do things. What's that in Navy? 1, 1, 1. It's 3, right? All the way around that tile. And then at the top, I got one more 1 to pick up, right? So now let's go pick up all our pieces. Sorry, I need to make sure this doesn't look like negative because that was just pointing. Right? That was just pointing to here. So how many X's? How many X's? 1 here. And we still have this X. Because the minus 2 doesn't stop this from being part of X. So we got 2 X's. But then... 1, 2, 3, 4, 5, 6, 7, 8. Oh. 8 minus 2. 6. Questions. So do double I. I don't know why we switched from A's and B's to I and II, but do double I with your team.
I have one question.
Yes.
If you have more negatives than, or more like S minus whatever.
You can't have a negative length. So X is going to have to be something big, right? If you end up with something X minus, X has to be something big. Does that make sense? A length cannot be negative. I'm going to color code this, so get a head start on me. Everyone have your drawing on your paper? Okay, I'm going to start color coding. So if you got colors, pull them out if you want. Ooh, how long are the butts of the X? 1s, always. Maybe we should do like a best notes competition. You have to like anonymize everyone's notes, right? So people could vote anonymously. Check what I have up on the screen, see if it makes sense. We're about out of time, because time flies when we're having fun. Question marks fly when you throw them around the smartboard.
Where'd you go?
Somewhere down in the abyss, probably. They bounce. If you guys didn't know, smartboards bounce. Alright, so X across the top of the X across the side of the X, and then the ends of X are each one, so we get 2 here. Any questions so far? No. The bottom along the rectangle X's, still X in length. 2, 3 around the little bump out, 3 around the little bump out here. What would be my red section? What were we missing here and here? Yeah, it's X minus 2. So now hold up, I still got like 3 minutes. I don't know why we're packing up. I see binders. Well, okay, the algebra tiles I'm alright with. Let's pick up all our X's. 1, 2, 3, 4, and everything's positive, so sweet. 4X. And then let's pick up our constants. That's what we call those numbers that we know, right? The constants. 3, 6, 8, 10, minus 2, though, 8, 4x plus 8. Huh, that sounds familiar. 4x plus 8. I think we heard that somewhere before. Huh, I wonder if that was intentional. A liar? Whoa! Big words. Really big words there. If you need 4.3.2, check your binder right now, because I know like Katie needs 4.3.2, unless I gave it to you this morning. Check your binder, make sure you have 4.3.2. It has the math notes on the front about combining like terms. And then we're out of here. You need it? Or wait, or did I give it to you on Monday? I checked your binder. I think I gave them out on Monday so you guys would have the notes. It looks like this on the front. Let's double check. Why are people shoved in the folder? We might have to fix that at lunch. Gotta be organized. Hey, congratulations again. You guys won. Keep it up. Keep those homeworks coming in. Marina, Vincent. Come here real quick.